How are you, my friends? This video is presenting questions 29 to 42, which is Group C from the 70 Old Exams Review questions for the complete algebra course, lectures from 1 to 39. So this is question 29. If 3k is the vertex of the parabola, 3x squared plus 2mx plus 8y is equal minus 24. Find the value of m times k. This is a multiple choice question. First, we rearrange the function, and instead of y, we put f of x, so it will be minus 3 over 8x squared minus m over 4x minus 3. So here we have a minus 3 over 8, b minus m over 4, and c is minus 3. So to find the vertex, we look at h minus b over 2a. And we know here from the vertex, h is 3. So I put 3 equals minus b over 2a. So I find m to be minus 9. So I need k. Now k will be f of h, f of 3. So I replace 3 in the x here, see? I already found m is minus 9. So k will be 3 over 8. If I multiply m times k, so it will be minus 28 over 7, which is the answer B. Now question number 30. Given two functions, f of x square root of 2 minus absolute value of x minus 1, g of x 10 over x squared minus x, find the domain of f plus g. To find the domain of f plus g, we have to find the domain of f intersection the domain of g. So if you look at f separate here, we take the radicand, 2 minus absolute value of x minus 1 greater than or equal to 0. Rearrange it, then we have absolute value less than or equal to 2. This is case 2 in lecture 26. So x minus 1 between minus 2 and 2. Then we add 1, we get closed interval from minus 1 to 3. Now in the G, the domain, all real numbers except the zeros of the denominator, which is 0 and 1. So all real numbers except 1 and 0, or 0 and 1. Then we have to find the intersection. So this is domain of f down from minus 1 to 3 closed, all of this. Domain of G, all real numbers except this 0 and this 1. Find the intersection, 3 parts. So we say closed minus 1 to 0, open. Union 0 to 1, open. Union 1, open to 3, closed. Now this is a complex number. All this value is equal to p plus qi. Find the value of p over q, which is the real part and the imaginary part. We have to simplify inside, then we take squared of the whole quantity. Now we have I cubed is minus I there. Square root of 40 is 2 outside times square root of 10. Minus square root of minus 5 is square root of 5i. Square root of minus 2 is square root of 2i. So this will be I and I squared, that's minus 1. With this minus becomes plus. So now this term here becomes at the beginning square root of 10. Minus 2 square root of 10i squared. Now we can use the formula a minus b all squared will be a squared minus 2ab plus b squared. Simplify that, you get 10 minus 40i minus 40 over 1 plus I. Now we multiply by the conjugate, 1 minus I. In the denominator, we multiply complex number by the conjugate, so it will be a squared plus b squared. And up we multiply by FOIL method. So minus 70 minus 10i over 2 will be minus 35 or minus 5i. This is p and q. Then we divide, you get 7. Solve the polynomial inequality. This one times this one less than 0. For sure here we have to continue factoring. This is factored, but not completely. We never multiply. So we say Factor completely, we continue the factoring. This is x minus 2 all squared. This is x minus 3. This is x plus 1. You see the first one here is all perfect squared. This is minus 2x minus 3. It becomes x minus 3x plus 1. So I find the zeros, 2, 3, and minus 1. I make a big table. I put all the factors here. I choose a test point. Then I take the result negative. Where is the negative? Between minus 1 and 2 union 2 to 3. You cannot make it one answer here. You cannot combine from minus 1 to 3. Why? Because 2 is not included. See, if you replace x equal 2 there, it will be 0 less than 0, which is not correct. Now, given this function f of x is the absolute value of x plus 1 minus 5, find this expression. So we have f of this minus f of 1 over h. H is less than 0. So I take this value, minus 3 plus 2h, inside the x. That's an easy question. Just replace it there. And then f of 1, replace it also in this function 1. 1 plus 1 absolute value minus 5. This becomes minus 2 plus 2h absolute value. Now we know h is negative. So this is negative, so we have to put minus outside the absolute value so that the whole answer is positive. Cancellation minus 5 plus 5. Then you will have minus 2h over h, cancel by h, and then minus 2 is the answer. Given the complex numbers z1 and z2, simple and easy, write all this in standard form. We need 2 plus 1 over 5i, z1 plus z2, minus z1 times z1 bar, that's the conjugate, minus I to the power 94. We need the whole answer in standard. So what do? Just replace z1 there, 3 plus I, see z2, 2 minus I, and here z1 is 3 plus I times z1 bar, 3 minus I, that's the conjugate. I to the power 94, 94 divided by 4, and the remainder is 2, so this is I to the power 2. Now, this one, I will be cancelled, so that's 5. Multiply 5 times 2 is 10. 5 times 1 over 5i is I. And this is the formula here, 3 squared plus 1 squared. So that's 10, cancelled with this. I squared is minus 1 times the I plus 1, so 1 plus I. Looks easy. Solve the rational inequality, 1 minus 4x less than or equal minus 1 over x minus 1. So rearrange the inequality, move all the terms to the left side. Just a little note here, please, never multiply on both sides of inequality by the LCD if it contains any variable, because it might be positive or negative. Combine the terms on the left, see all this. So there is an LCD, least common denominator, x minus 1. So I take the one here, I multiply up and down by x minus 1. In the middle, I multiply by x minus 1. In the last term, I multiply by x up and down. And this is less than or equal to 0. Simplify all this, you will get x minus 2 squared over x minus 1. So we have to make now a table of signs. That's the given. And this is after we rearrange it. So the zeros are 0, 1, and 2. Just make a big table here. You know, just put all the factors. Choose a number test point. And then we have to choose all the negative. Where is the negative? From 0 to 1. Open. Why? Because in the denominator here, we cannot accept 0, we cannot accept 1. Union the 2. How do we know the 2 is there? Because if I replace 2 in the whole inequality here, 2, 2, 2, it will be 0 less than or equal to 0, which is correct. So 2 is part of the solution. Here we have a straightforward question. We have a function piecewise. We have minus 3 constant. We have absolute value. We have a greatest integer function. And now we have another function separate, g, and we need to find f plus g of minus 3, g circle f of 11 over 4, f times g of 2. Just replace each number in the proper function. Let's start here, minus 3. So it will be f of minus 3. We see where is minus 3 in the f, plus g of minus 3. I replace it in the function g. Now here, you have to check 11 over 4. What is this number? If you divide 11 over 4, it would be 2.75. So 11 over 4, we go to f here. Where is 11.5? So this is f of minus 3 first. It's a minus 3. G of minus 3, I replace 6 minus minus 3 will be square root of 9. Now inside 2.75 between 2 and 3. See, I go to the greatest integer function. I put 3 minus 2 times x, 11 over 4 will be 11 over 2, which is 5.5. So this is minus 2.5. You know the greatest integer will be minus 3, and then the whole answer 3 over 14. Evaluate the expressions. We have two parts here, very similar, same numbers, 3 to the power half times 1 over 9, all to the power 1 over 4, divided by this. Same numbers, instead of this multiplication, we have here addition. So you will add this plus this over that. And here we have this times this over that. Each one has a different answer. Now the first one in the multiplication, I think it's maybe easier, yes. Change everything to 3, the base 3. 3 to the power half, 1 over 9 will be 3 to the power minus 2, multiply the power, and 9 here is 3 squared, multiplied by 3 over 4. So we change everything. The idea here is to base 3. We add the powers there, 3 power 0, that's 1, over, and this is 3 to the power 3 over 2. So this is the square root of 3 cubed, which is 27. So 1 over 3 square root of 3, rationalize it in the denominator, and the answer is square root of 3 over 9. Now in the second one, we can split the fraction here, a plus b. See, this is a plus b over c. I can split a over c plus b over c because we have the same denominator. Then I change everything to base 3. And here when I divide with the same base, I subtract the power. Please check the numbers and you get 4 over 9. Really nice questions. Now, we go to the shifting here. If the graph of this y equals 3 minus x over 5x minus 9, shifted 1 unit down and 2 units to the left, find the new equation, which is y equals ax plus b over x plus c. Write it in this form. After that, you pick up a, b, and c and multiply a times c plus b. Okay. Now, 2 units to the left. You see, you have to check here. 2 units to the left. That means x becomes x plus 2. So every x up and down, everywhere in the equation, this is the given, and this is the aim. So every x here, I put in the bracket, x plus 2, x plus 2. Now 1 unit down on the y. So y will go to y plus 1. So I have one y there, so I put y plus 1. I can move this plus 1 on the other side, becomes minus 1. And then I simplify the whole function until I reach y equals minus 6x over 5x plus 1. Now look at the aim here. See, it looks like a is minus 6. X, there is an x, nothing there, so I put plus 0. You see, plus 0. But down, if you look carefully here down, x plus c. So I need no number here, the coefficient 1. So just divide every term here up and down by 5. So it becomes minus 6 over 5x plus 0, or 0 over 5, it's 0. X plus 1 over 5. Now a minus 6 over 5. B is 0, C is 1 over 5. Just multiply AC minus 6 over 25 plus the 0, which is the B. So the answer minus 6 over 25. A little tricky question. Write an equation of the line passing through the vertex of the parabola f of x times x plus 14 minus 7 bracket 2x minus 1, and perpendicular to the line 10 in the bracket y plus x minus 10 is equal 11x. So what do we have to do here? We have to rearrange the parabola. See, multiply the brackets, and then we'll get 14x, you see, and minus 14x cancel. So that's very easy. X squared plus 7, just the parabola shifted up 7 units. So the vertex 0 and 7. So that's a point on the line, because the line passes through, see, if you look here, the line passes through the vertex. So we find the vertex 0 and 7. Now let's arrange the line. And in the question also, these lines are perpendicular. If you arrange the line here, see what you just multiply, 10y, 10x minus 100 is equal to 11x. The y will be 1 over 10x plus 10. That's the equation of the line. So here we see the slope 1 over 10. The lines are perpendicular, so the other slope will be minus 10, because the product should be minus 1. Now find the equation of the line we need, y minus y1, mx minus x1. We know the m is minus 10, and x1, y1, 0, and 7 is the vertex. So the equation y equals minus 10x plus 7. That's what we need. Find the domain of this function. Straightforward question, not difficult. You have a square root, and then we take everything under the square root, the radicand, all of it together, greater than or equal to 0. So this is ready. Factor it. Find the zeros. Big table, because we have x plus 3, 4 minus x, 4 plus x. Be careful about the table of signs. Then you have to choose the greater than 0, which is the positive. Just make sure, I said here, take the positive, make sure you remove all the zeros in the denominator. So when we have 4 and minus 4, see 4 and minus 4, it should be open. That is the domain of this function. Now, if this polynomial over x squared plus 3 is equal to x squared plus m plus nx plus k over this, find k divided by m plus n. This is the k value divided by m plus 1. So this is like an exam type. Well, this one, we have to use long division. Wow, divide this polynomial by this polynomial, so we have to use long division. This is the long division here. Oh wait, this is the long division, yes. So we take the highest power, you know the story, divide by the highest power is squared, multiply x power 4 plus 3x squared, you subtract here. So this will be canceled, and this will be minus, this is 5x squared. And then you repeat the process, divide the highest with the highest, you get plus 2 until, when do we stop here? Because the power here, the highest power in the remainder is less than the power in the divisor, so we stop. So now this is the quotient x squared plus 2, and this is the remainder 5x plus 21. So now we can see here, k is the last number here, 21, m is the 2, n is the 5, 21 over 7, the answer is 3. Find the domain and range of this circle. You have to complete the square on the x, complete the square on the y, and then you find the center and the radius, you draw it. Very simple circle. It will be x minus 4 when you complete the square, y minus 3, squared is equal to 4. So see the center here, very easy, 4 and 3. Go to the right and left 2, because the radius is 2, up and down 2. So you see the domain will be 2 to 6, and the range on the y will be 1 to 5. That's the range, and that is the domain. Thank you for watching. This is part C. If you like the video, please, you can subscribe and share it with your friends. And then I hope I can see you in another video with another topic. And let's wait and go to group D. Thank you very much.